Hello friends, myself Borhade Ganesh. Today learn about op-amp can be used as a adder or summing amplifier. Operational amplifier, that is the IC741, can be used as a adder or summing amplifier. Adder means if more than one input signal apply to the inverting or non-inverting terminal of the op-amp, then the output is the addition of the input signal. Therefore, this circuit told as a adder or summing amplifier. Okay. Then see op-amp used as an adder. It is possible to apply more than one input signal to an amplifier. This circuit will then add all these input signal to produce their addition at the output. Means when apply the more than one input signal, then output of the op-amp is the addition of the input signal. Such circuit is called as an adder or summing amplifier. Depending upon where the input signal is applied to the op-amp, depending on that, there are the two type of the adder. First one is the inverting adder and second one is the non-inverting adder. Inverting adder means when apply the input signal to the inverting terminal of the op-amp, then output is the addition of the input signal and output get inverted. Then this adder is known as a inverting adder. Non-inverting adder means when apply the input signal to the non-inverting terminal of the op-amp, then output is the addition of the input signal and output and input are in same phase. There is no any inversion. Then this circuit is known as a non-inverting adder. Then first is the inverting adder or inverting summing amplifier. This is the circuit of the inverting adder or inverting summing amplifier. The VA, VB, VC, these are the input signal applied to the inverting terminal of the op-amp through the current limiting resistor R1, R2, R3. I1, I2, I3 are the current flowing through the resistor R1, R2 and R3. IF is the feedback current that is flowing through the resistor RF and the non-inverting terminal that is connected to the ground. Okay. Then see the expression of the output voltage. Apply the KCL at the node voltage X. At this node point, apply the KCL, means Kirchhoff's current law. Then Kirchhoff's current law is the input current is equal to the output current. Therefore, equation is the I1 plus I2 plus I3 is equal to IB plus IF. IB is the base current flowing through the inverting terminal of the op-amp, and it is very negligible because due to the very high input impedance, the current flowing through the inverting and non-inverting terminal is the 0. Therefore, IB is equal to 0 and it is very small. That is the negligible. Therefore, what is the equation? I1 plus I2 plus I3 is slightly equal to the IF. Then calculate the value of I1, I2, I3. Therefore, I1 is equal to, I1 means the current flowing through the resistor R1. Therefore, I1 is equal to VA minus V2. Minus V2 means suppose this is the non-inverting voltage is the V1 and inverting voltage is the V2. Then I1 is equal to VA minus V2 divided by R1. Okay. Then I2 is equal to, I2 is the VB minus V2 divided by R2. And I3 is equal to VC minus V2 divided by R3. And what is the IF? IF is equal to V2. This is the inverting voltage V2 minus V0 divided by RF. Then put the all the values of I1, I2, I3 and IF in this equation. Then this is the equation VA minus V2 divided by R1 plus VB minus V2 divided by R2 plus VC minus V2 divided by R3 is equal to V2 minus V0 divided by RF. But due to the virtual short concept, if the one terminal at the ground potential, then another terminal also at the ground potential, right? Therefore, due to the virtual short and virtual ground concept, V1 is equal to V2 is equal to 0. Then put the V2 is equal to 0 all over. Therefore, what is the equation? VA divided by R1 plus VB divided by R2 plus VC divided by R3 is equal to minus V0 divided by RF. Then calculate the equation for V0. Therefore, V0 is equal to minus RF in bracket VA divided by R1 plus VB divided by R2 plus VC divided by R3. Therefore, V0 is equal to minus RF by R1 VA plus RF by R2 VB plus RF by R3 VC. This is the equation for the summing amplifier. This is the required expression for the summing amplifier. Then, if take the value of R1, R2, R3 is equal to R. All the values are equal, that is the R. Therefore, equation become V0 is equal to minus RF by R, VA plus VB plus VC. If again RF is equal to also R, means all the values are equal, then the equation is the V0 is equal to minus VA plus VB plus VC. This is the equation for the adder. This equation shows that output is directly proportional to the addition of the input signal, that is VA, VB and VC. This minus sign indicate that output get inverted. Therefore, there is a minus sign. Okay, because the input signal applied to the inverting terminal of the op-amp. The summing amplifier is also known as a scaling amplifier. If each input voltage is amplified by different factor, the circuit is then called as a scaling amplifier. Means all the values of the resistor R1, R2, R3 and RF are not equal. Then what is the equation? V0 is equal to minus RF by R1 VA plus RF by R2 VB plus RF by R3 VC. Okay, means this equation indicate that each factor or the each input is amplified by the different factor, means the all the values of the resistor are different. Then this circuit called as a scaling amplifier, means take the scale of the each resistor is different, therefore it is known as a scaling amplifier. Then second, the summing amplifier is also known as a averaging amplifier, means the output voltage is equal to the average of the input voltage, then it is called as the averaging amplifier. For that purpose, if R1 is equal to R2 is equal to R3 is equal to R and RF by R is equal to 1 by N. Suppose there are the three input signal, then RF by R is equal to 1 by 3. Okay, then put these values in this equation, then V0 is equal to minus VA plus VB plus VC divided by 3. Okay, this equation indicate that output is the average of the input signal. Then second point is the non-inverting adder. Non-inverting adder means more than one input signal when applied to the non-inverting terminal of the op-amp, then this circuit is known as a non-inverting adder. Then output is the addition of the input signal. Okay, and the output signal and the input signal are in same phase, means there is no any inversion. Okay, this figure shows a summing amplifier in non-inverting configuration. Okay, if input voltage and resistor are connected to the non-inverting terminal as shown in figure, the circuit can be used as either a summing amplifier or an averaging amplifier. Okay, then first calculate the value of V1. V1 means that is the node voltage. To calculate the V1, add the three input signal, that is VA, VB and VC. Therefore, V1 is equal to that is the average of the three input signal. Therefore, V1 is equal to VA plus VB plus VC divided by 3. Okay. Then, hence the output voltage is given by V0 is equal to, it is the non-inverting amplifier. And the equation of the non-inverting amplifier is the V0 is equal to 1 plus RF by R1 V1. 1 plus RF by R1 is the gain of non-inverting amplifier. Okay. Then this in this equation put the value of V1. Therefore, V0 is equal to 1 plus RF by R1. Then value of V1, that is the VA plus VB plus VC divided by 3. Okay. If 1 plus RF by R1 is equal to 3, means adjust the value and the summation of or the addition of 1 plus RF by R1 is equal to 3, then what is the output voltage? V0 is equal to VA plus VB plus VC. This equation indicate that output is the addition of the input signal. Okay, thank you.